We just finished our unit on polynomials, and we talked about how to multiply polynomials. So we're going to start with just a quick refresher of kind of what we just did. So if I have this first term here and I multiply, I've got to multiply and distribute each piece to solve this problem. So this would end up being 4x to the third minus 2x to the second, and then plus 6x. So what we're going to be doing today is going backwards. We're going to be starting with a problem and working backwards into the factored form. So this here is the factored form when we've pulled out a greatest common factor and then seen what was left. So let's start with A. So we have 12mn squared minus 18m squared n squared. So we're going to find the biggest factor that we can pull out. So we'll look at our numbers first and think of the largest number that can come out of both of them. So I know that's 6. Then I'm going to look at my variables, have m and I have m squared. Remember, I'm looking for the smallest exponent of the m because I can't pull out a 2 m squared out of just an m. So I know I can just pull out an m. And then I'll look at my n. I have an n squared and an n squared. So I actually can pull out n squared out of both of these terms. So then I use parentheses. And I say, well, if I pull out a 6 out of 12, think about dividing. 12 divided by 6 gives me what? 2. If I have already pulled out an m, I don't have an m left anymore. And if I pulled out an n squared, I don't have an n squared anymore. You can think about m divided by m is just 1. We don't need to put a 1. N squared divided by n squared, they cancel each other out. It's just 1. So that 2 times 6mn squared gets me back to my original problem. So now let's look at the next term. I bring down my negative. Then I say, how many times can 6 go into 18? So think about division. Well, 3 times. Well, I've pulled out an m. So remember, think about if I have m2 and I took out 1, I have 1 left. And then I had an n squared and I have an n squared and I took it out, so I don't have anything left. So this is fully in factored form. All right, let's try another one. So this one has 3 terms. I'm still going to look at the numbers first, and I'm finding the largest common factor that can come out of all of those. Well, I know 5 is my smallest number, so there's nothing bigger than 5 that I can actually pull out of 5. So 5 is going to be my number. Then I'm going to look at my variables. I have an a squared, and an a. So I can only pull out an a. Look at my b. I have a b in the first term, but not in the second or third term. So I can't pull out a b. It has to be in every term. Let's look at c. I have a c, and a c. So I can pull out a c. Now let's see what's left. So you're thinking about 5 times what got me back to 20? Well, 4. Well, I pulled out an a, so there won't be an a left. I pulled out a c, but I do have a b left. So think about when I multiply back, this should get me back to my original one that's not factored. Bring down my positive. 5 will go into 15 3 times. Then I have 1a left. I've taken out a c, so that's all I have, plus 3a. If I multiply back, 5 times 3 is 15. A times a is a squared, and then c. I get back to my original term that wasn't factored. Bring down my negative. 5 will go into 5 one time. Nothing C, so I know that's only 1. Don't put 0. You have to think about how many times 5 can go into 5. 1 time. And I know if I check back, I get back to my original problem. All right, I want you to try C and D and see how you do. So C is pretty straightforward, and on D I did something a little bit wrong. I didn't find my greatest common factor, and I want you to see what will happen if that is the case. Because some of these numbers get big, and you may have picked one that you thought was the biggest, but really it's something bigger. So notice when I pulled out 14ab, I ended up with 2a and 4c squared inside my parentheses. Well, 2 and 4 share another common factor. I can pull out more. So I did this to show you always want to check to make sure that you factor completely. So this one, I'll make a kind of a note for ourselves that we need to factor bigger here. So when we look at that, if we're at this point, we can pull out a 2. So think about, we already have a 14ab out here. We're going to now pull out another 2, so it's times 2, and I'm left with a plus 2c squared. Now, I don't want to leave it like that, so I want to fix it. 14 times 2 is 28ab, and then a plus 2c squared. This is fully factored, so I can't factor any further in my term, so I always make sure that you have completely factored. All right, let's look at e. Now, e, same premise, but notice I have all these negatives. So sometimes that throws people off. Now, you can pull out an x. Obviously, they all have an x. And I could do that, and I'm going to be left with a negative x to the fourth, a negative 4x to the third, a positive 23x to the second, and then a negative 1. That's perfectly fine. I also could have pulled out a negative x. That's perfectly fine too, because notice that they have some negatives. It just changes my signs. So remember, a negative times a positive gets me back to the negative I started with. So the only thing that would be different would be x to the fourth. All the signs would be different, but it's still correct. Okay, so it's your preference. It's still going to be a correct factored solution. So either one will work. Okay, now we're going to go to a 3-star, and this is a little bit different. I want to show you. So we're going to first look for our greatest common factor. Well, 2 can come out of both, so I'm going to pull out a 2. And I'm left with x squared minus 9. And we would think we're done. Well, there's something a little bit different we have to think about. So when we learned special cases, we talked about things that could multiply and a middle term would cancel out. So this is something called a difference of squares. And we will go into more detail about this through the unit. So this is a difference of squares. So earlier in the year, we talked about perfect squares. Well, remember what x squared means. That's just x times x. And then think of 9. Is there a number that times itself will get us 9? Well, it's a perfect square. 3 times 3 gets us 9. Okay? So we pulled out a 2. He's going to sit out here and watch. But now this will actually factor down further as a difference of squares. Remember, when middle terms cancel out, and there's nothing in the middle term, we had one binomial that was positive and one that was negative. So we're going to take one x, put it here, the other x, and put it here, then our 3's and 3's. So this would be x and x, 3 and 3, and this is fully factored. So be careful and always look to see if there's difference of squares. You're looking for perfect squares and a perfect squares, and it has to be different. It has to be a subtraction symbol there for it actually be. If I got something at the end was x squared plus 9, I cannot factor any further because this is not a difference of squares. I can't do x plus 3 and x minus 3 to get back, and if I do x plus 3 and x plus 3, I'd have a middle term. If I did x minus 3 and x minus 3, I'd still have a middle term. So this cannot be factored further. This is not a difference of squares because it's got that plus symbol there.